So let's go through the material list, and I'm going to kind of walk through the stuff that we're going to use for most of the hands-on labs. And we'll actually use these pieces later on when we actually build. The intent is we're going to build out a bunch of different breakout boards and then build a motherboard that you put these all on that allows you to route from the ESP32 to the 5351 or to the real-time clock, setting your output through an amplifier, through the low-pass filter, taking the input, bringing it through into a TALO detector, and then out through an audio amplifier. So we're going to kind of build this up in modules, go through each module. So some of this stuff we can do in all breadboarding, but then the last thing we'll do is build out that motherboard, and then you can just put the pieces in.
Hey Jim,
so let's go ahead, Roger.
Let's talk for a minute about the parts and things people need to order. If you haven't already ordered already, there's 2 items that, on Amazon that are going to take a little bit of time to get there. I've ordered earlier this week or last week, and I've received everything but 2 parts, and that's the little RTC I2C module Arduino. That's about somewhere in early July to end of July kind of part. And then there's the if you want to use that little frequency counter tester, that's the kind of end of July or mid July part. So some parts, everybody doesn't need to order a complete resistor kit or a complete electrolytic capacitor kit or whatever like that. We can share the cost of some of this. I think several of us have already ordered their stuff and gotten stuff in, but you will need your own like breadboard probably, and if you want to do that, but as far as all the ceramic capacitors and things like that, you probably doesn't everybody need to order one of those. So if you haven't already ordered your stuff, you might talk to Jim or myself or one of the others that's already ordered their parts and see if we can split those.
Well, and I did create a thread out in groups.io. So if you guys have extra parts, and I guess I should probably also put out some alternative links, but I know I have several real-time clocks. I have a couple of GPS modules extra. I have a couple of the power supply modules. And I do have an entire what do I want to call it, cabinet full of resistors and capacitors that you guys can come and steal. I've got a giant 6-foot cabinet full of electronic parts from stuff. So when we get into building those, mostly we're just going to use standard capacitors in that. I did create a list out on Mouser when we get into the when we start building the low pass filters, that where you can buy everything. And I think to build a filter from 10 meters up to I think 160 meters or 80 meters, it's like $14. When we get to that, I'll post it out there a week before or so. But if you find something you can't get, or you can't find like 3 of them, but all they got is 8, ask the group before you go buy 8, because I'm sure we have plenty of them. And that way you can just, it'll make it easier, and you can pick it up or whatever when we start doing things over the next week or so. Like at the next club meeting, people can bring their excess, and then you can pick it up from them there. So let's go through the different pieces that we're going to use. So this is the material list. So the first thing is going to be the ESP32 Dev Module, and this one I suggest that you actually get it from the link I gave you at Mouser, because this is from Expressive Systems directly. It also is a 30-pin system instead of some of these other ones that are only like 24, 26. So There's more outputs, which is going to help us when we start adding multiple things together. And some of the stuff that I found on Amazon that I've ordered in the past, when you actually look up the chip, it turns out that they are actually old chips that Expressive says that they're end of life and you should not use them for reference builds or anything. Now that doesn't really hurt us any, but I can't guarantee that it's going to work 100%. And so let me jump over here to my overhead view, and you can kind of see the chip here. I might need to turn off this light. I don't know if you guys can see that any better or not.
No, it was fine, Jim. You don't need to turn it off.
Okay, well, let me turn it back on then. So that's basically it. It comes with the feet already on it, so you don't have to solder them in. This big black thing here is actually the antenna for Wi-Fi. So this dev kit actually has built-in Bluetooth and Wi-Fi. So not only could we use it as a Bluetooth device, like if you wanted for Bluetooth streaming and that, but you could also control it via Bluetooth if you wanted to by sending commands to it. It actually, there are libraries here that actually that you can pull down that will give you a full-blown web server. And so if you wanted to build a web-based interface for, let's say, your Whisper transceiver to control it, what frequency, what bands it's on, what your output is going to be in that, you can actually do that over the web, and we may get into that. We might also look at ways to do cat control via that way as well. The next thing we're going to be needing is the real-time clock breakout board. And like you said, Roger, they're back ordered, but actually as long as you search Amazon and look for an RTC I2C module that uses the DS1307, there are other ones there. I think, Scott, you got a couple of extras. I know I've got quite a few extra ones. Let me switch over here to the overhead view and I'll show you what this looks like. Let me move this out of the way. So that's the chip there. Let me bring it up here so you can see it. It kind of gets off focus. And it actually has a CR2032 chip on the back that basically keeps the clock running when the power's off. And then you've got, let's see, there's your I2C pins, your clock and your data in, plus your voltage and your ground, and then there's a data select out so that you can put multiple of these together. If you wanted to have multiple real-time clocks, you just use the data select to address them.
I think I picked up one of the ones that you told me to pick up, which is a High Let Go. That's the DS3231 AT24C32 clock module. I've got like 5 of those.
Yeah, and I think most of the library we're going to use will work with most of these as long as the command structure that they use over I2C is the same. But I don't think we'll run into too many problems with it. So if you do get something different, that's fine. But don't worry about it. If you can't find it, like I said, I've got several that I can sell somebody. The next thing is going to be the 5351A breakout board. This one I think came in a 3-pack, and it was relatively inexpensive. It uses a 25 megahertz crystal. There are some that come with a 27 megahertz crystal. The nice thing about it is you can either solder on antenna, SMA connectors on the board, or you can use the pin out. If you notice there's a 0, 1, and 2 pin out there, you can actually pull the signal off of that instead of using the actual SMA connector, which is what we're going to do from a breakout board perspective. We'll pull the signals off of the pins, and I'll just give you an overhead view of what that looks like. You know what I ought to do? I'll make this a little bit easier. I got to get into my Mevo app here, and let's see. I'm going to connect to this guy, and I'm going to zoom in. Oh, that's not it. Wrong one. Let's see if I can make this. Can you guys see that a little bit better? Or is it still kind of out of focus?
It's all good.
Okay.
Yeah.
But, I mean, and actually the way I've got this setting here, if your board doesn't come with the pins already mounted in it, if you have an old piece of breadboard, that's the easiest way to solder those pins, is to stick that in and stick it in, put a resistor or something underneath it, and then solder your pins. And in that way, it makes it a lot easier to deal with than trying to balance it in that. Okay, the next part that we're going to be using is, let's see, is a rotary encoder. And I don't think I brought one of those with me. But what this is going to do is, depending on where you turn it, whether clockwise or counterclockwise, it's going to actually count upwards or downwards. And it does this digitally, so you get a clock pulse. And what we're going to do with this is we're going to use it for our tuner. Now, Colin sent me a really nice Adafruit rotary controller, but they're like $70. And it's like a big, heavy, I want to call it jog wheel that you can wire in. So you could use it for, like, if you were, like you would on a face of a radio. But this will work perfect. This also has a push button in, so when you push it in, it will actually pulse as like a momentary switch. So we can use that, and we can be looking at that on the ESP32 to kick into a menu mode or whatever. So we'll use this basically to tune on the band that we're on, and then we'll use the push button part to kick into a menu, to change bands, to change step frequency and stuff like that when we actually get into programming it. The next thing is the OLED screen, and this is a very small screen, but we don't really need a really big one. If you would rather use like a 16 by 2 LCD display, I have some of those. I'll be more than happy to give you, that runs over I2C. But this is an inexpensive display that will give you a really good display that we can use on this, what our frequency is, what mode we're in, or whatever. And it has a really nice, easy to use library. You could even send out GIFs across it and do animations and stuff like that. But this, again, it uses I2C to talk to it. So you basically send a command, and then it will paint your screen for you. It actually, you can even do custom fonts and stuff with that as well. And then this is the overhead view of it. And again, it's just like I said, a very simple. I think it's probably about 1 inch by about 1.5 inches. You can get bigger ones if you find this hard. Just make sure that it's an I2C based display, and double check to make sure there's an Arduino library for it so that you can drive it, so you don't have to try to program it yourself. And I guarantee you, if you find it on Adafruit, which they'll have a library for it for Arduino and for ESP32 and that. So you shouldn't have problems with that. And then the GPS breakout board, again, we're going to be using this mainly for timing and for the real-time clock that comes in from the GPS, and we're going to use it for calculating our grid square when we're doing stuff like Whisper or FT8 and that. And here's a picture of the actual breakout board. It does come with a little antenna. You can get them with a longer antenna. So if you want to put it in a closure or something, you can mount the antenna on top of it. But it's very simple. We'll, like I said, we won't be using a lot of it. I know that with QRP Labs, there was an entire thing about using the GPS chip to measure the drift of the clock, or of the 5351 output, to automatically compensate the frequency based on whether it drifted or not. So there's different things that you can do with them besides just get your GPS coordinates in that in the time. Okay, the other thing, like Roger said, if you don't have any resistors in that, once we start, I would hold off on this because, like Roger said, I know I have a bunch of these. I'm sure he does. But that kit is all the most common values. You'll use some of those, like the 470 ohm ones we use for LEDs. Usually the 2.2K and the 10K we use for divider networks when we're doing things like sensing voltages and that into the. We'll build a resistive divider network and use two 10K resistors and read the voltage from in between there. Several things you can use them for. I think this kit was about $10, but it does have all the standard values. Was one of the reasons I had put it in here. The same way with the capacitor. I've got tons of capacitors. So when we get to it, if you don't want to go out and buy it, just get up with me and I'll pull what I have. And then same way with the electrolytic capacitors. But I was trying to find something that had all the standard values that was inexpensive. If this is going to be the only project you do, it may not be worth it to buy each one of those kits and just get what you need from somebody else. And then the other thing you're going to need is a breadboard. Now you don't. This one here has got, I think it's what, 1, 2, 3, 4 separate channels on it. So you've got plenty of space when you're breadboarding to spread things out, which is really nice. You don't have to have everything cramped up, but if all you've got is, let me bring this one back up here. If you didn't want to spend, I think it was like $30, you could get just one of these very simple ones like this, which is just basically 2 rails and stuff. You'll just have to play with how you place stuff on it. But the other one, you've got plenty of room here. Like if you notice, I guess you can't really see that, but down here in the bottom, I've got the power module, and I've got it plugged in here. So I basically going to run the power up those 2 rails there. But then I can also jump over here, and I got plenty of room to put my like if I wanted to put my OLED down here, I can put my OLED down here. Now I've got so much space on this board. it's, it's ridiculous. And if I wanted to put the real-time clock, I could put that up here. Same way with the 5351. So, we've got plenty of space here where we can put stuff. So that's the main reason I was suggesting that one. So you have plenty of space.
One thing we're going to learn in this class is efficient board layout. And, there's 9 ways to skin this cat. But, there's probably just a few ways to make it really efficient for space and wiring. And, with high frequency stuff, you want to keep a lot of your wiring as short as you can. So it's not always good to have too much room to spread out, because then you get sloppy with things then.
Well, you also get parasitic signals and stuff. You might pick up something and wonder what's going on. That's very true. Usually you want them to be as short as possible. And I'm sure we'll run into that. I know I've ran into some things that I was like scratching my head and I'm trying to figure out what was going on. And then when I moved them closer together, it went away. But especially when we start dealing with RF frequencies, like when we're going through a low pass filter and that, you're going to want that to be as close to your mixer and your signal as possible, so that you don't you don't get extraneous signals.
At the same time, we don't want to just be copycats. We want to learn from the experience and try to come up with your own way to lay things out and stuff like that, and do things. So don't be afraid to experiment. And if one way doesn't work, ask questions or try again, kind of thing.
Yeah, and that's the good thing about this, is because when we put something together, you may run into something and it, you find out it's easier to do it a different way because the pin's on the other side or whatever. What I'm going to present is going to it's just going to be something that I put together as I was working through it. It may not be the most efficient. When we sit down and we start talking about the schematic and the PC board design, there are going to be some things that we're going to look at, and we'll look at how can we move things around, because you don't want to just throw everything on the circuit board and have KiCad actually do an auto routing, because you'll get the ugliest looking thing and your signals will be all over the place. So we will take some time to be very meticulous with how we lay out parts when we actually design the boards. The other thing you're going to need is jumper wires. You can do this yourself if you've got some small gauge copper. You can build the jumper wires. Telephone wire is really good. And then the other thing I'd put in here was, go ahead, Roger, I'm sorry.
I just say you can make your own, as plenty of colors. These jumpers are nicer, the long wire jumpers, but for the small jumpers like that, RG6 or telephone wire, all kinds of things are good for that. It's the perfect wire, color coded.
Yeah, and matter of fact, let me pull this out. Oh, it's taped down, is it? Oh, these guys. Well, anyway, I mean, I'll switch over here to the overhead view. I mean, these have anything from 125 millimeters all the way down to 2 millimeters, which are really good for little short jumpers. And I'll actually go through and show you how we'll jumper the board in a certain way so that your rails will have like 3.3 volts down one rail, 5 volts down the other if you need 5 volts, how to extend them over. And that's why you'll be using these jumpers, is sometimes to run your voltages in that. Now, the other thing I put in this list, and these are all optional things, you do not need to buy any of these, because we will make sure that we have these on hand during build days and that. But the first thing was a very simple frequency counter, inexpensive. How many people have an MFJ 259C or D or B antenna analyzer?
Yep. Have you?
Well, that actually has a frequency counter built into it, and so you can actually use that instead of spending $20-$30 for one of these. The other I can't remember if I'm pretty sure the Rig Expert probably also will do a frequency counter.
Yeah,
I
it
don't
does.
think the stick does. I don't. Does the stick do it, Roger?
The what? The stick?
I
Yeah,
don't
it
think the
does
stick
TDR.
has
It
a.
does TDR. It does everything.
Oh,
Um,
okay.
I will also have a HP, pretty nice, benchtop frequency counter there. That's fairly accurate down to on temp places. That. So
Yeah. So I mean, this is good when you're looking to see your frequencies and stuff like that. But it's not a must-have because you probably already have a device that does it if you've got an antenna analyzer. The other thing that comes in handy when we start playing around with stuff is a DDS Signal Generator, and this actually has a built-in counter to it as well. I have one of these that I will be bringing to the build days, so that we can use because sometimes
yeah,
you need to put a signal on and to drive something so you can test things out. But
I have a scope that has a signal generator as well, so we'll bring that as well.
Okay. The other thing that will come in handy, especially when you're building filters and that, is a spectrum analyzer. Now this is the tiny SA. This is much like the Nano VNA. It's a very small spectrum analyzer. I think they were about $50. I think I can't remember. I'd have to go look again online. But this will go up to 960 megahertz, which what this is really good for is if we build a filter and you want to run a signal through it to see where that filter drops off and whether it's working properly in the proper frequency band area. If you're doing a bandpass filter or a low-pass filter, I will have my spectrum analyzer there. I've got a Rigol DSA815 that I'll be bringing with me as well. But if you're looking at, hey, I need something to do it, but you may have a ham friend that owns one already. So don't go out and just buy it because Jim had it in a list.
Yeah,
So if
those
anybody did
also can
buy,
be used to inject a single frequency signals as well.
yeah, that's true. I didn't even think of that. And then the other thing is an inexpensive oscilloscope. And this one here, I was looking for very small or cheap ones, inexpensive, that was at least had a 100 megahertz bandwidth and would go up to a gigasample per second. I've got a Rigol DS, 1052E, which mine only does 50 megahertz, but it is 1 gigahertz per second sampling. This thing here, I think, was $150, and it's basically a tablet oscilloscope. You can also get a USB device that'll plug in and you use your laptop. But again, this is just a nice to have. If you're by yourself, you don't have a friend that has one, and you need to use one. This comes in real handy when we start talking about IQ signals and signal generation, and you want to look at your output to see what it looks like and how's it shaped and stuff like that. This is a good way to look at your circuit and see that. But again, these are all optional. We will have these at the build days for you to use. So if it's like you don't have a frequency counter and you can't do the calibration right away, wait till our in-person build day, and that can be one of the things you can do is you can borrow the frequency meter, set it up, hook it up, and then run the generator or the calibration program and get the calibration figure for your 5351. Or if you want to look at the outputs and stuff like that, that's what those build days are for, is to do the things that in person and get some help out.
And I'll have a number of scopes with me, so we won't have a pile up at any one instrument there. So
Yeah, You know, and I thought I had the power list. I thought I had the power piece in here. I guess I did not.
It is.
It is
It's
in there?
Yeah,
Oh, okay.
I didn't see it in that.
it's there.
What one is it?
The RST?
No,
No,
what I'm talking
power
about is this
supply.
guy here.
Yeah, that.
So this is this basically is a little, it's got a 7803 on it and a 7805, and it takes a 9-volt input, or you can use a USB, and it's got a little push button on it to turn it on and off, but it sits right along the rails of the breadboard. I will post a link to this out there, but
Show me
show
me the lower corner of that, down next to the USB connector. I think I'm looking at the
lower
robot.
Yeah,
Down next to the USB.
I think I had it. I don't know what this says here. Next to the USB, this one just says HW131. But let me pull up a browser here in a second. But I will put a link to it. But this is a nice, easy way, because you can actually set this up for 5 volts on one side and 3.3 volts, and then just plug in a 9-volt battery. Let me see if I can find it here real quick. Can you guys all see that? So you can get these. This is like 2 of them. I got like 8 of them for next to nothing. I will post, and there was also one where you could do 3. But I have like at least 4 of these modules that, if somebody needs one, you can get with me at the club meeting, and I'll get you one. But I will also post a link to it out there in the group. But like I said, it comes with a little 2.5 mil or 5 mil 2.1 jack that goes to a 9-volt DC end, and you plug it in the black thing, and then you've got an on-off switch, and then you also could use a USB to power an external device, or you can actually use that to power an external device, but then you have output headers so that you can switch between 5 volts or 3.3 volts, and if you pull it off, then you have nothing. Or you put it in the middle. It basically has no output out. And it fits perfectly across a standard board. And so I'll make sure that link is out there in the net. I think that's everything material.
Can't you order that part without the breadboard though?
Yes, you can. And if you'll hold on a second, I'll see if I can find it in my order list. Let me. I just got to minimize some things here so I can get to it.
I thought I did. I'm looking for it here.
Do you have any idea what the total parts cost is, not for extras, but just for the minimal amount needed?
I do not. I'd have to go in and figure it out. Scott, what did you spend total? I know you got extra parts, but
with all the extra parts and stuff, right under 100, like 150 or so.
Oh, really? All that? Okay, so I didn't realize it was that much.
Boards, I bought multiple boards, multiple parts. Yeah, I was feeling wealthy that day.
Oh man!
Right after Ham Expo, and he was fat and happy.
That's
I guess
right.
He was. So now let me go back here to the browser here. So this one here I'm sharing right here. So like 3 of these are $7.99. So and you can just order them without it. A set of 8 is $12.99. So
put the link up in the chat thing, Jim.
I will.
Grab the share thing there and just put it in the chat thing.
I know with those 3-for-1 deals on those little power supplies, you end up needing at least 2 when the magic smoke gets let out.
Yeah.
Yeah. Well, and that's why it's always good to have have a couple extras like that. And like I said, I will also make sure that this link is actually in the group in groups.io. But yeah, I would like I said, I've got at least, well, I bought the 8 set, so I know I'll probably hang on to 2 of them. So I've got maybe 3 that I could sell like 2 a piece. You know, so you have one and then have a backup. My motto is if you have one, you have none. So
Yeah.
it's always good to have an
one is
extra.
none, 2 is 1.
Yeah.
I know
Okay.
where you got that.
I think that's everything to talk about the materials that we're going to use. And again, there'll be some other extra pieces, small pieces that we'll need. So like when we're building out the low pass filters in that, like I said, the cost for all the MPO capacitors that you're going to need is about $15. And then you'll also you'll need to get some toroids. And the nice thing is, if you go to kits and parts, and I will have this link out here, but they actually have a it's kitsandparts.com, I think. They actually have a like a toroid kit, and it's that you can get, and it has everything that we're going to use. They have all sorts of stuff out there, and they have some really good resources on things. So let me switch back over here. This is at kitsandparts.com. But like he has, if you go out here and look at toroids, you know, you can get like, we're going to be using like 37-2s, 37-6s. I have several of these, so before we go out and buy them, we'll see what we actually need to get, and maybe we go in and we chip in and we get 100 pieces, and everybody ends up paying a couple of bucks. I think the only other one we would need would be the T50-6, I think, if you're going to do a little bit higher power, but he's got a bunch of little stuff here that comes in handy. And like I said, he's got some really good kits and stuff like that. But we won't need that right now. It'll probably be July or August before we're at a point where we're actually building these. And you will need to get some magnetic wire, but I have a ton of that, so I don't think anybody needs to buy any.